We make an array in MATLAB by using semicolons to separate the different rows of the matrix. So for example, if I want to make 1, 2, 3 in the first row, 4, 5, 6 in the second row, then I separate them with this semicolon. So what if I want to make a bigger matrix, a bigger array? How can I do that? Well, there are some built-in commands in MATLAB to make it more easy. For example, zeros. If I type zeros 2, 6, what does that do? That gives me a 2-row, 6-column matrix of all zeros. Okay, and there's another one called ones. For example, 1s, 3, 5. Okay, that gives me a 3x5 matrix of all ones. And I can use these to make other constant matrices also, other matrices with the same number in each coordinate. So for example, say M is 1s, 3, 5. Okay, so there's M. And what if I want to have 6s everywhere instead of 1s? I could do M equals M times 6. Okay, I can also add. I could do, now M is all 6s, I could do M equals M plus 100. Okay, now it's still a 3x5 matrix, but it's 106 in each coordinate. So what if I wanted to make a matrix like 1, 2, 3, 4, 5 in a row? One way I could do it is V equals 1 to 5. And then I could say something like A equals, then I say first row is going to be V, next row is going to be, how about V plus 5, next row is going to be V plus 10. So what did that do? I said first row was supposed to be 1, 2, 3, 4, 5, next row was supposed to be 6, 7, 8, 9, 10, and so on like that. And this isn't a way that I could make a huge matrix, like having to write the plus 5 and the plus 10 by hand is a little annoying, but later on when we talk about for loops, then we'll have an easier way to use this kind of idea to make a big matrix with almost any kind of pattern we can describe. Some important functions related to matrices. We've already talked about size. For example, if I do size of A, okay, what that returns, it returns a vector, and that vector has a 3 in the first coordinate, a 5 in the second coordinate. That stands for 3 rows, 5 columns. One that we haven't talked about before is length of a matrix. What that returns is the longer of the different dimensions. So in this case, it's 3x5. 5 is the longer one, so 5 is what's returned for length of this matrix. Another command that's important, especially if you've studied linear algebra, is the transpose command. So for example, say I do A, and then I do a single quotation mark after it. What does that do? That forms what's called the transpose of the matrix A. And the way to think about it is the first row of A, suddenly it's going to become the first column. Second row becomes the second column, and so on like that. So let me first write down A. There's A, and here's A transpose. So you can see, for example, the second row of A, that's now the second column of A transpose. And the second row of A transpose, that's the second column of A. If I want to change just one coordinate in a matrix, let me show you how to do that. Say I have capital N equals zeros 3 by 10. And then say I do N of 2, 8 equals 13. So what did that do? That said, take the matrix N, look in the second row, the 8th column, and make that entry 13.